Welcome. Today we'll be going over our Python project, the team project that we've been working on for the past 2 weeks. So let's get into it. So we have 4 team members here today that have all contributed towards the project. There's Dylan, Jonah, Mike, and me, Matt Craig. So getting into it, we're going to do an overview of the code. Each one of us is going to go over the code a little bit. First, we're going to start off with the main function. The main function starts off by asking the user to enter the name of the file they want to enter. In this case, there's a couple of certain requirements that the user needs to follow. For example, the entered file needs to be a PNG file, and the file also has to be at least 50 pixels by 50 pixels large in order for the algorithms to run correctly and produce a good image. That's what this asks for. The second while loop asks for the threshold value and makes sure that it's between 0 and 1. So when it runs the threshold function, that it performs properly. Now we're going to get into the picture functions in the other file. On Grayscale, we'll have Dylan go over that.
All right, for our Grayscale function, what it practically does is it takes every pixel and it goes left to right on each row. It takes every pixel and multiplies that array, which has 4 components, and it multiplies the first 3 components by individual values. For the R component, it's 0.21, the G component is 0.71, and the B component, which is the third component, is 0.07, and it multiplies each of these components, and it creates a new value, which is grayscale. And after it does that for for one pixel, move to the next pixel, and after it completes one row, it'll move to the next row, and it'll continuously do this until it gets to the entire picture.
Thank you, Dylan. So now going on to the blurring. This is our largest function. So this also created another array, and what happens is that the function, like the grayscaling function, goes through each and every pixel, go on rows, so it'll go down the row on each one, and it takes the average of all the surrounding pixels. For the corners, for most middle pixels, we were able to take 9 total pixels because you can take everything from the surrounding. For the edges, you can only get 4 to 6, depending whether it's in a dead corner or just on a side. But that is the overlook of the blurred image. After that, it's saved and into a photo as well, a PNG photo. So these next 2 functions perform the same task, just for X and Y edge detection. The X edge detection uses the X edge detection matrix to multiply to the pixels. It uses the same format as the blurring function. It assigns each pixel with how bright the value is, so everything's naturally already set to 0, and then the value is then set to the average of all the pixels of the original image. Once this is completed, it then does the same thing for the Y with the Y edge detection matrix, and then they're both returned and then given to the edge enhancement, which Jonah will go over.
So the edge enhancement technique that's used in this project is the Sobel operator, which is the square root of the X array plus is the square root, and then the X array squared plus the Y array squared. And so for each pixel, the X edge that was detected will be squared, and then the Y edge that was detected will be squared. And then when that's square rooted, that will give a composite image, a composite edge combined for the X and Y for each pixel in the entire image. And then that result will be the composite edge.
So now the returned array from the edge enhancement is then given to threshold, which threshold uses the same ideas as before. It runs through the entire image, but it uses the composited image and uses a threshold that was given earlier by the user. And if values fall below it, it is set to white, but if values above it, which mean that they're edges, they're set to black. We'll see this in a couple minutes when we do a couple tests. We'll actually get into that right now. But first, we're going to start off to showing a couple of error checkings. So we're going to run this, and if you open this file, this has our pictures in here, and we have an example of this one that's a JPEG file. Now, naturally, the image read will take in the JPEG file, but we want a PNG file. So otherwise, our algorithms will not work. So in this case, if we use mat.jpg, it will actually not allow you to use it because it will say entered image needs to be a PNG file. This is checked through the algorithm. The next one, we can also just type in anything, and it will just say the file cannot be opened. That's because there's an error, and we also have an error handling for that one. So now moving on, we will demonstrate our two. So we have our Purdue that we're going to use first right here. So we're going to type in purdue.png. We're going to type in our threshold value, which is already naturally set to 1. In this case, we're going to use 0.2. Here we have the, it's now printing the progress through. We have progress bars that show the process of how it's working. So it's going to go through all that. You can see here it's telling you what the function is, and then it shows it down here, the progress bar. And then at the end, it goes through, and all the files have been saved. And so we're going to go back over here and take a look. So here's the original image. We then have the grayscale image. We then have the blurred image. We then have the X detected one. And then we have the Y detected one. Following this, this is the composited image that's put together. And then finally, this is the threshold image that is put together at the very end. The next one we'll use is a custom photo that we found. This is just a statue. So we're going to run this again. And then we're also going to be using 0.2 for this one as well. The progress bar allows people during it to know what's happening. So it tells you that it's grayscaling the image, and then it tells you the progress that's happening. This can be very useful for the user, so it doesn't look like the program has just frozen and is not doing anything. This at least gives them feedback so that the user knows what's happening. So the process is done here, so we can go take a look at the saved images. So this is the original, like we just showed you. This is the grayscaled image. This is the blurred image that is rendered. And then the X detection, the Y detection, the composited image, and then finally the threshold image that is produced from all of this. Thank you for taking the time to look at our project. We've put a lot of work into this, and have a great day.